Okay, so we start again after lunch. So this was not an easy presentation for me, like the one of yesterday, because this is a work we actually just began one month ago or 2 months ago with the other co-authors, and so maybe it's a little early to be presented. And I think it will be a little bit boring also for you, because it's a lot of definitions and criteria and standards. It will be something that for sure we will discuss in the next 2 days within the large carnivore group. So there are not lots of pictures, and so I put this picture, which actually is the Large Carnivore Initiative for Europe group. And in the last meeting in Porto, we actually decided to go a little bit deeper in some topics, as Luigi just said in Italian, and one of those was actually to try to find monitoring standards for the large carnivores populations in Europe. There are many documents. Lots of the large carnivore populations in Europe have their own, like the one I discussed yesterday for the ALPS, that is shared within the other countries in the ALPS. There are other monitoring standards in Germany that share it with Poland, monitoring standards in Scandinavia, and so on. So the idea here was not to write another monitoring standards with all the details on the protocols of collecting the data or on the methods. It was more to find the criteria behind, to kind of being able to pull together the data with some categorization. And that probably will be helpful in what we do, like Petra's work. First of all, I will come with some definitions, because we started working on this topic with the group that you saw. So there were some specialists, some bear specialists, some lynx specialists, and some wolf specialists. And the first point was actually to define some words in order to use them in the same way. So this document starts with some definitions, because when we started the discussion, we thought, no, we need to define what we mean, because of course all the terminology sometimes can have some interpretation. So first of all, survey, these are the two that Luigi likes, right? That we need to differentiate. So survey is actually the assessment of the status of a parameter at one time and over an area. And that's usually what I described yesterday, for example, for the survey that we conduct over the Alps to estimate the population size and distribution of wolves. So survey is at one time, monitoring is the repetition of the same survey, where the goal actually is to infer on the change of a given parameter. Here, what are the objectives? So the objectives of the discussion, of course, when you define a survey or a monitoring program, the first thing is to define the goals, the objectives, what you want to estimate. And so here, the overall goal is always the status of the large carnivore populations, but we decided to actually focus on two parameters, which are the distribution and the abundance, and actually measured by the area of occurrence and the population size. We had some discussion within the group, because of course also the genetic status evaluation of a population is a key parameter to monitor over time, so we could go there, or the health status, but since these are the two most important parameters that we actually estimate for all the population and we make in our documents, we stopped here because the discussion could go a long way. So given these two parameters to be surveyed and monitored over time for the different large carnivore populations, we decided that we're going to produce and finalize a document which has two goals. The first one is to actually find an agreement on the monitoring standards for large carnivores populations in Europe, to estimate these two parameters, considering the categorization of data and the criteria for data interpretation. So mainly what you need to actually pull together the data. So we will not go methods and other stuff. Mainly these two things in order to call let's say, data and the data interpreted in the same way. The second one, it was discussed also in Portugal, is to find an agreement on the levels of quality of the statistic measures that can be provided given the different survey context. In other words, once we provide the population size estimations for the different large carnivore population, we actually base this estimation on different data qualities. For example, you saw what we have done in the ALPS in the past 3-4 years, or maybe you know how the work is conducted in Germany or in Sweden. These are high quality data sets for sure, versus there are other populations that are, maybe they are larger, it's more difficult to conduct the monitoring, there is less funding. We had the LIFE WOLFALPS project which could allow this kind of estimation. So for sure we give numbers, but these numbers are not the same. And so matching these numbers with a quality index would be helpful to actually recognize what we have behind those maps. So the goal here was to try to find, and it's not done yet, we need to discuss this a little bit further, to agree on the levels of quality of these statistic measures. Take into account, we consider three main variables which actually could affect the quality in general. So first of all, the size of the population. So large populations are just harder to estimate versus small populations. The sampling designs, actually if there is no sampling design at all, you have less power and so less quality, versus if you have something structured with a solid and robust sampling design, then you have more power in these estimates. And third, if you can have appropriate individual identifications within the population, then your estimates are more powerful. You can apply capture marker capture models, so you need individual identification. For bears and wolves, that means genetics, and for lynx, it's not only genetics, it can be also pictures. Okay, but the goal is having individual identification. That really makes a difference. So we consider at the end, let's say, these the three most important variables that could affect the quality overall. So given this, so we went a little bit forward, and why this is important. Okay, three more definitions. The population parameter, so what I will call the population parameters, also the population attribute, is a characteristic of the population that we want to measure, we want to estimate through a statistic measure. So in this case, the abundance and the distribution. But what we do, it's an estimate. Actually, it's not always an estimate. So we made this distinction between estimates, which are all the estimates of animal abundance, but not only, also this occupancy distribution, where the estimate actually take into account the detection probability somehow. Okay, there are different ways. But if you take into account the detection probability, then you really have an estimate. And then, so you produce a statistic measure, that it's a measure, if we talk about population size, of absolute abundance, with a certain level of precision, so it's standard error or a confidence interval. And so that's the best. Sometimes, or most of the time, we don't have estimates, but we have indices. So what's an indices instead? It's okay, a good measure, but it's more a field count of animals or their signs, which actually contains information about the relative abundance. So we don't have a direct estimate of what's there, or we don't know actually what's the difference or how accurate we are actually on the true estimates of abundance. But it's very important when we actually want to monitor a population, because if the index is constant in its error over time, then it's a good way to have data on trends. That works very well. So for monitoring, it's good too. The only constraint is if for some reason, these indices are influenced by other factors, like a difference in effort over time that you didn't evaluate, and so a change in the index doesn't reflect actually a change in abundance, and that could be a problem. And so doesn't have the same power, an index, as an estimate. So when we want to go to qualities, we just give a higher number to estimates versus indices. Why this is important? Because in what Petra just explained, we have those maps. These are the old ones, we'll have the new ones, but pretty much what you have in here, or this is the relative science publication, or in here, when you actually have the population size, we have all the numbers together. And for somebody who doesn't really know what's quality, they just take all these numbers at the same level. But maybe after one of these numbers, there is a huge effort, a standardization, a sampling design, and whatever, and behind some other measures, there's not. And so it will be important to match those numbers with a certain quality level that will make this more explicit. Okay, that was the goal. It's not really easy. So for sure we will need some discussion on this. So we did this large overview on Ilka. Could kind of find and put together all the documents in Europe related to monitoring standards and reports related to this argument. We could see pretty much that population size concerning large carnivore have either been estimated by guess numbers, by expert, so expert guess numbers. And after a little discussion that will continue tomorrow, we think that on the long term, especially now with the Trump's area, with everybody is an expert, maybe we should kind of think about this. Because maybe it was more powerful 10, 15 years ago. Today, we put science in a bad position. But we can discuss this tomorrow, so this is a first draft. Second, what is done is the minimum counts of individuals, for wolves also the minimum counts of packs, which are the detected one. Detected with number of genotypes, number of animals counted with no tracking, by photo with camera traps, or a combination of those data. This is an index, okay? That's not an estimation. An estimate with a confidence interval. Then we can have robust CMR estimates, which these actually are models which incorporate the detection probability and need to have individual identification, and these indicate estimates of precision. And then we saw that for large population, distribution models have been used where actually you extrapolate from the area of occurrence, which is easier maybe to estimate with the use of some rules which relates the area of occurrence to the number of individuals, estimate the population. This is pretty much what we have. Then we went a little bit deeper in our document. And then we have also the area of occurrence that pretty much is either the minimum area with the cells like the one that Petra showed that can be highlighted if a species is detected with all the rules of buffers or not, or actually, and that's an index, or actually the estimates of occurrence where you take into account the detection probability, and so you go to the estimate with confidence intervals, okay? So given this, the goal, let's take the first one. I just have a few slides. So let's take the two goals. So the first one was first to find a general agreement on the monitoring standards, taking into account the data in calling, to arrive to call the data in the same way. And so, first of all, the agreement on the categorization of large predator signs that usually we saw more or less everywhere are based on the SCALP-C criteria that have been developed by SCALP on the links, where actually all the C1 data are the hard facts. So what's sure, like the genetic proof, some very good photos or a dead animal. Then you have the C2 that are confirmed observation, which usually are the ones that are confirmed by an expert, and the C3, the unconfirmed, that usually are not used. So this has been developed by the SCALP, so it's adapted to links. What has been done is that wolf biologists adapted these C categories to wolves with different rules, because maybe some photos are C1 for lynx and some photos are C2 for wolves, because they can be sometimes not so clearly distinguished from dogs as well, tracks. And the same for bears. So we need to define those also, because the different countries maybe give little differences among these. It will be great to have a minimum common denominator over those definitions in order to everyone fit on those categories. And we will see how to define, but at least to have C1 and C2 and C3 common all over Europe. The second one are the criteria for the data interpretation. So when do I call a cell, for example, for occurrence occupied? Do I need 2C2, 3C2, 1C1 and 2C2? So everybody can do that a little bit different. And so let's arrive also to common standards on those to have everything equal. Not just for the area of occurrence, which is easier, but for population size, which is more difficult. And so what's necessary to actually document a pack? Do we need 2C2, 2C3, or something like that? So that's pretty much the discussion. So at least at the end, we will have one pack that we know if there's a pack, it's because we have this kind of data that says a pack. And versus lynx and bears. So we are trying to agree on categories of data and criteria. And that's probably the easiest part, and we would like to arrive there. And that document will kind of bring together all the ones that are made over the different populations. The second goal is the agreement on the levels of quality of these statistic measures. We said, of course, that an estimate is better than an index. Let's try to give this quality index. And so we consider these three variables, which I just told you, and tried to put the statistic measures that you can derive of these parameters, given the different contexts, considering the two parameters. So for each parameter, you will see we made a table where actually we consider the 3 variables mainly that can affect the quality. So the small versus the large population, there was some discussion in this, and we can continue that tomorrow. At the end, we say the small is less than 250 mature individuals, and large is more than that. So for a wolf pack is less than 125 packs. Then we define structures versus unstructured sampling, and structured is considered when you have a sampling design with some time frame or organization in order to collect the data and be able then to apply some modeling on that, especially capture marker capture or occupancy versus unstructured. And then appropriate versus inappropriate individual identification. So having individual identification through genetics that actually allows to perform some estimates. So appropriate in space and in time if you need trends. And so given this, we try to see what can be estimated and how. So let's see the what. We try to produce this simple table, where actually you can see the variables, so small versus large population, unstructured versus structured, and if you do or you don't have the individual identification. I make you one example for wolves, then we did it for lynx and for bears, but again, it's under discussion. And, but it's pretty much summarized what you can have. In this case, for wolves, we wrote genetic because appropriate individual identification means genetic analysis. For lynx, it's not just genetic, it can be phototrapping as well. So we filled these tables where we said, given the context, so given those variables, what the maximum we can have. So if you have a small population and a totally unstructured sampling and you have no individual identification, so here, like the first line, you just can have an index. So you can estimate the minimum number of individuals. If you get here, or if you move to here, for example, so if you have a small population but a structured sampling, and you also have individual identification, then you can actually have an estimate with standard errors, probably applying a capture, microcapture, robust estimate, and so you can still have the index, but you can also have the estimate. And so we kind of try to see where we can arrive given the context. I hope I could explain this. We did this for population size, and we look at the methods that can get us there, and for the area of occurrence. So based on this map, then with the same map, we try to say, okay, what's better quality? So of course, if you are in this place, you can. So of course, if you are in population size, you have a small population, you have a structured sampling, and yes, you can have appropriate individual identification, you have a high quality estimate, so it's 1. If you are in another side, then your quality goes up, given always the case that estimates are better than index and everything in structure is okay. And we proposed this idea to go from C1, C2, and C3 to Q1, Q2, and Q3 that could match our tables and maps. That's it. That's pretty much where we are. There will be 2 days of discussion on this, and hopefully we will arrive to produce a document that will be helpful for everyone. Okay.